Okay, this is solved. You notice there's a link over here. If you want to click on this hot link, it'll bring you to another individual solving this. So I saw this on the web, by the way. And what I want to do is go to the whiteboard and solve the problem. All right, so let me do that. And the first thing I'm going to do is I'm going to write down the problem. And the problem is x to the natural log of 4 plus x to the natural log of 10 equals x to the natural log of 25. They go on to say that x is a real number. Furthermore, x is greater than or equal to 0. One solution I see right off the bat is 0. Because 0 to the ln 4, the natural log of 4 is a positive number. 0 to the natural log of 10, natural log of 10 is a positive number. And x to the natural, I'm sorry, it's 0. Let me get my eraser out. It's going to be 0 to this positive number, ln 25. And this is going to be 0 plus 0 equals 0, and that's certainly true. So this is what some people call a trivial solution to the problem. Now let's take a look at other solutions to the problem. And I'm going to write this down. We're going to simplify the logs. And the natural log of 4 is the same thing as 2 natural log of 2. And the natural log of 10 is actually going to be the natural log of 2 plus the natural log of 5. Now somebody said when you rewrite things, you're in a dead end. It could be. I'm not saying make it more complicated, but I'm hoping to see a pattern in the problem. Just by rewriting, sometimes you'll see a pattern. And over here, I'm going to get 2 ln 5. And again, 25 is 5 squared, bringing the 2 down. So what I notice now is that I'm dealing in a realm of x being greater than 0 now, because I already have that, and I know the restriction over here. So looking at this thing over here, I'm going to say it looks sort of quadratic, and I'm going to write this down as x ln 2. This thing is being squared. The next one, a little stranger though, isn't it? I'm going to write down using rules of exponents, this is x ln 2 times x ln 5. And what goes over here, this is going to be x ln 5 quantity squared. All right, what I'm going to do now is make a substitution. And the substitution I'm going to make is u equals. I'm going to say u is equal to x to the ln 2. And I'm going to say v is equal to, this just makes it simpler to write the problem down now. Whoops, I didn't mean to put that down. So it's going to be equal to x to the ln, I did it again, x to the ln 5. And what do you get there? You get u squared plus, let's see, that's going to be uv now. And that's going to be v squared. All right? So I'm going to solve that for 0. It looks quadratic in form, and I'm going to see if I can use the 0 product rule on it. And you get v squared minus uv minus u squared. Okay, I can't factor that, but I can use the quadratic formula. So I'm going to say v equals, what goes on the bottom? Twice the coefficient on the v squared term, so it's 2 times 1, which is 2. Then it's going to be the opposite of the coefficient on that linear v term. That's going to be minus a minus u, which is just u, plus or minus. It's going to be the coefficient on the linear term, which is the coefficient on v, which is going to be minus u, but I have to square that, and that would give me u squared. And then minus 4 times the coefficient on the v squared, which is 1, and then times the constant term, which is not a constant, it's just simply u squared. And it's going to be minus u squared, so this is plus u squared. All right, this is kind of shaping up, and v equals u plus or minus, this is 2, this would be the root of 5u squared. All right, and before I go on, I want to point out that I made some substitutions over here. Maybe I should write this down over here. And I hope you remember that x is greater than 0. What does that mean? U is greater than 0, and v is greater than 0. All right, that's important. Let's go back over here and simplify this. What do you get? You get u, this is 2, This is still plus or minus until I figure it out. The root of 5. Now since u is a positive number, not 0, its square root is just u. All right? Now looking at this, I know v is a positive number, so I'm left with a problem here, and I can't have the plus or minus. So what do I get? I get u plus root 5 of u. It couldn't be minus, by the way, it would be a negative number there, because 1 minus root 5 is a negative number, over 2. So I get v equals u, and let's write this down now. It's 1 plus root 5 over 2. Now you may recognize the number, but that's not important, all right? So what do I do now? I got to go back and figure out, I don't want u and v, I want x. So I wonder what v is. I can't remember. So go back over here, and that was x ln 5. And u was x ln 2. Yeah, let's write that down. Times 1 plus root 5 over 2. Now what I got to do now is I got to find out what x is, and this is pretty complicated. And what I'm going to do is I'm going to take log of both sides. So I'm going to take log of both sides, that's natural log, of x to the ln 5, and the natural log of the other side, which is x ln 2 times 1 plus root 5 over 2. All right, left side's not that bad. Rules of logs, I get natural log of 5 times the natural log of x. I'm just using rules of logs. Next one's going to be a product now, so right as a sum. So natural log of x to the ln 2 plus the natural log of, let's see, 1 plus root 5 over 2. All right, let's keep moving. ln 5 ln x equals ln 2 ln x plus, I'm going to simplify this a little bit. I'm going to say natural log 1 plus root 5 minus the natural log of 2. I want to get the x on one side, and you're going to get ln 5 ln x minus ln 2 ln x equals ln 1 plus root 5 minus the natural log of 2. Well, I'm going to factor out ln x now. And what do you get? ln 5 minus ln 2 equals ln 1 plus root 5 minus the natural log of 2. I'm going to divide both sides by the coefficient on the natural log of x, and you're going to get the natural log of x is equal to natural log 1 plus root 5 minus the natural log of 2 all over the natural log of 5 minus the natural log of 2. Right, I want to get x, by the way. And how do you get x here? I got to rewrite the log as an exponential. So x will equal e to that power. Let's write that down. Natural log 1 plus root 5 minus the natural log of 2 over the natural log of 5 minus the natural log of 2. Again, if you want to use a calculator to approximate that, you can. Get a feel for it. It's about 1.7, all right? Now, my claim over here is that a lot of times you make mistakes and misunderstand problems. So it's nice if you can, maybe use technology to see if you can verify your solution, by the way. And so how would you verify the solution? Well, I want to point out to verify the solution, you have to go back to the original problem, which is one over here. We've already plugged in a 0. We know that's a good answer. I did find another answer. It's an over here. This is another answer, by the way. That you have to plug it in, check it out, all right? So I want to go back to the notes. And by doing so, I want to point out in the notes, we write the solution up for you. But again, I do recommend you look at this guy do the problem. Now, I didn't watch the full video. I watched part of it. I like this guy. He displays some pretty good problems over here. And I don't think it's a difficult question. I do think it's one that takes you some time to think through, though, by the way. And I would encourage you to do that. But anyway, I write the work up for you. It's typeset for you. And I put a more detailed solution down over here. I also want to put a Sage code over here. And so what'd you do over here? I put down the left side and the right side. And I'll go through this as well in the Sage. And then I try to solve it. It can't do it. Try to find the root of it. And it certainly, it gives me the root of it. I want to verify that that really was the same thing as this guy over here, all right? So I also want to put a helpful graph. And what I do, I graph both the left and right-hand side. And I do see them intersecting at a point, by the way. What point do I see them intersecting at? I see them intersecting at this X value, all right? Again, I will post the Sage code for that. And I think the graph is pretty self-explanatory. But with the application I'm using here, it's on Mac OS X. It's called Grapher. It's not bad software, all right? Although it's dated, it really is old. Thank you for paying attention.